Now this illustration deals with 3 or more current carrying conductors in a raceway in accordance with NEC 310.15 C1 as in car. Now before we dig into this information, let's review the note 1 and 2 first, as well as the NEC loop. Now note 1, let's look at that and review it together. It says here C240.4D, which limits the size of the overcurrent protection device to 15 amp number 14 conductors, 20 amps for number 12 conductors, and 30 amps for number 10 conductors. Note 2 then states, each current carrying conductor of a parallel set of conductors shall be counted as current carrying conductors if you exceed 3. Now let's look at the NEC loop. For calculations in figure 8-12 and design tips on the left-handed side of page 8-8 review. Now let's review then the quick calc for the say the short time current rating of a number 12. It's to the left of the illustration. And the short time current rating, you take the circular mil of a number 12 wire, divide it by 42.3, the constant. So a number 12 wire, according to table 8 to chapter 9, 6,530 circular mil divided by 42.3, we have a short time current rating, 154 amp. Now, we shouldn't have a protective device at 3 times its rating for a circuit breaker and 5 times for a fuse exceed the 154 for that number 12, so that we do not damage insulation. And that was a good rule of thumb that we used. Now notice, that's for 5 seconds. Now with the illustration calculation, quick calc, to the right using time-delayed fuses, in the square root now, we would take the current and square it times the clearing time divided by the clearing time of the device. So if you had a half cycle clearing time of a time-delayed fuse, multiply that by 0.0167 and you get 0.0084 clearing time. Now when the math is done here and you take 154 as we calculated for the short time current rating in Calc 1, square that, 154 times 154 times 5 seconds, which is the clearing time for 154 that we're using, divide it by the new clearing time of 0.0084 second for half cycle. The insulation on that conductor, on that short time current rating by clearing it so fast is 3,757 amps. Think about that. That's a lot of amps. Why? Because you're not allowing the current to flow over the copper or the aluminum for more than 0.0084 seconds. It just doesn't have time to heat that insulation up like it did for 5 seconds in Quick Calc 1. Now, let's look at the, and remember, if you have 3 current carrying conductors or less, there's no derating factor at all or adjustment factors in accordance with our table 310.15 C1. So looking at step 1 to the left, 3 current carrying conductors in a raceway, table 310.16, a number 12 conductor in the 90-degree column in table 310.16 has an ampacity for THHN of 30 amps. Application now of derating factors 310.15 C as in car 1, 3 current carrying conductors has no derating factor. So 310.15 C1 and 240.4D working together we would have 30 amp is the long time current rating of that conductor, but due to number 12 in 240.4D having to have a 20 amp overcurrent device supplied, it's really only good for 20 amps because of 240.4D without we're feeding a motor or a compressor or something like that, where the authority having jurisdiction would allow table 240.4G to be applied. Now to the right, we have 4 current carrying conductors. We have exceeded 3. So our table 310.15C1 is in car 80% for 4 to 6 conductors that are current carrying. Step 2, application of the 80% times 30 amps using the 90-degree ampacity now, which we know 110.14C1 along with 334.80 explains this in detail. We come up with 24 amps. 24 amps will supply a 20 amp circuit breaker and 20 amp overcurrent device at its 24 amp rating. So we know then that the 20 amp overcurrent device on the number 12 wire is good really for 24 amps, so the code is satisfied, and section 310.15C is satisfied where we had 4 or more current carrying conductors. And our figure 8-13 illustrates this. So keep this in mind when you're dealing with current carrying conductors in a raceway, and you sure don't want to exceed 9.